All right. Hello, everybody, and welcome to the stream. I hope everybody is doing well tonight. We are going to pick up where we left off last time, and we are going to tackle at least part of hot reloading tonight. I don't know how far we'll get, but I've done a little bit of thinking on how I want that to work offline, and we're going to go over that design. And we're basically going to rip out the old way of hot reloading, and we're going to make it a lot more easy to use, both from an API perspective and an understanding perspective as well. And so the goal of this whole refactor train that we're on right now is just to sort of simplify things and make things easier to use. So this is just another step in that process. But before we do that, I do want to take just a quick second to thank the supporters of the channel, beginning with our elite partner, Javier Olazaran, followed by our partners, GoBullies Inc. and Matt Oscar. Those are the highest tiers of subscription over on YouTube memberships and Patreon, followed by our supporters listed here on the screen. They are a combination of other tiers of support over on YouTube memberships, Patreon, as well as Twitch subscriptions. So all of this helps me cover the cost of running this channel, things like software licenses, hosting fees, eventually assets, things of that nature. So it does help me out a lot. I do really, really appreciate it. It means a lot to me that you guys support me. I don't have any sponsors or anything like that, just you guys. So thank you very much for that. And I would be remiss if I didn't mention a big thank you to all of the viewers, whether you're joining us live either on the YouTube side or the Twitch side, or if you're catching the VOD after the fact. Thank you guys very much for being here. Without you guys, this project would not exist, and obviously this channel would not exist. So thank you guys for being here. Spiro, you are indeed first. Welcome. How are you doing, buddy? Good to see you. All right, so where we left off last time is, I believe we actually did finish all of the import pipeline. So I'm marking that as done. We may have, a bug here or there to fix on that that we might run into with stuff, but I'm calling that done, right? So what we are completely focused on now, and this is going to actually wrap up this particular version, is the hot reloading system. So the way that it currently the way that it previously worked, I should say, because it doesn't currently work, was that we had this sort of resource system that we had to set a flag to hot reload, or watch for hot reload, rather. And that got passed down to our old asset system, and then that in turn again got passed down to the virtual file system. And that is actually what called out to the file system to actually have the hot reload, or the hot reload sort of get triggered, right? So we're going to rework that. We're going to make that a lot easier to use. And we're going to talk about kind of the overarching steps to get there. And then I've got some comments here in the code to go over as well. So basically the idea is that systems will register for some sort of a K asset hot reloaded event, and then handle that thusly. So the texture system would register for that event, and then when a resource comes through or an asset comes through, it would be able to handle that accordingly. And each system is going to handle that on its own, in its own way that it understands how to handle that, right? So that is sort of the high level of how that's going to work from the system perspective. So what we're going to have is we're going to wind up with a separate hit the wrong key. We're going to have a separate hot reload request call in the VFS. And this is ultimately going to return a watch ID. Actually, technically speaking, it's both in the VFS and the files, or the asset system rather. We are going to remove the hot reload Boolean option from the VFS request, and in the VFS request data, as well as the file watch ID that is currently in there, right? So we're gonna handle that a little bit differently. So whenever we watch a asset for hot reload, we are going to essentially be issued an ID for that. And then the way that that's going to work is anytime there is an event on disk that triggers this, the VFS will be notified thusly by the file system, and then it will go ahead and fire off a event. So right now we currently have a callback that is issued, and we're going to do away with that because that's kind of not the greatest way to do it in terms of, it's limiting. You can only have one, and there's just some other issues with it, right? So we're going to replace that and use our event system to handle that. And then we are also going to intercept that message at the asset system level and interpret how to handle that. More than likely, what that's going to be is that is going to be us determining how to actually use that new asset data for the particular asset, right? So we're going to have to figure out some sort of typing information when we're hot reloading an asset, right? So we'll have to think about that and brainstorm that a little bit. That's the only real hurdle I see in this entire thing. And then once the asset system kind of handles that, then it will fire off a reload event, which is accompanied by a asset watch ID or a file watch ID and a pointer to the asset, and then that is what the system is going to receive up here. So that's kind of the whole way that that's going to work. So there are a few layers of this that we're going to have to go ahead and take care of, but that is kind of the design that we're going to go forward with, and we're going to see how it works out, right? We're going to kind of explore that, and it looks like my power just went out. All right, it's back. Hopefully that doesn't happen again. All right. It is supposed to like storm here for a little bit, so I don't know. We'll see. Thankfully, I've got battery backups for stuff, but we will see how that works. Let me just check the weather really quickly. All right, well, we'll see. Weather's been kind of crazy. Anyway. Let's see. How many lines of code are we up to? Well, that's a bit of a mixed bag because we've actually been eliminating a lot of code. But last count, I think it was like 77 or 78,000 lines. And we're actually removing some and simplifying some stuff. So that number is actually going to drop. But the engine is actually a little bit more capable at the same time. So it's one of the reasons that like lines of code is not necessarily a great, caliber for, functionality and whatnot. But yeah, that is the last call. That's the last count I recall off the top of my head. I suppose I could do clock, right? Yeah, so we're down to 76,000 lines of code at the moment. And we've deleted probably about 15,000 roughly. So we had a bunch and now we're coming back kind of down. All right. Let's see. Thank you guys for the follows, by the way. I appreciate that. Hi there. Is a 16-core CPU worthwhile investment for game dev? I would say so, yeah. I've got a 32-core here, which is probably overkill for a lot of stuff, but yeah. You're going to need it, especially if you're handling, all aspects of game dev on your own, right? If you can afford it, go for it. I think it's worth it. It future-proofs your machine, allows you to multitask very easily. Let's see. New person here. How's the engine going? It's going well. Yeah, it's coming along. We're kind of bouncing back and forth between this and game code at the moment, but we identified some things that we're handling here in the various releases in terms of simplifying some things and some trouble issues that we ran into while trying to write game code. So that's kind of how it works with a new code base, right? Let's see. Also, where's the CSS coming from? I think the CSS is probably in... Oh, I wonder if it's counting the documentation folder in that. There's not too many lines of it, right? Let me think. Where is that coming from? It might be... Do I have... I don't think I have the documentation generated, because that's one place it comes from. So in here... no, I don't have documentation generated. Oh, yes, I do. Right there. It's the style CSS that I use for the Doxygen generation. So let me just pull that up real quick, because we've done some custom CSS in our API documentation. Let me see if I can like unflashbang this. I really need to. There we go. So yeah, our engine documentation. I did some CSS in here. I need to update it, obviously. In order to avoid flashbanging you guys, I actually used a plugin to turn that off. But yeah, this is where that CSS is coming from. So when we generate our documentation or auto-generate our API documentation, that's what that's for. The other day I saw somebody selling a 3970X CPU for like 500 pounds, but then realized how much electricity that would use. Yeah, it's fair enough. I have, what do I have? I don't even remember what I have, but yeah, the one I have uses a fair bit of electricity, which is why I sleep it all the time. Most probably buy a used 7950. That's fair enough. Yeah, that's totally fair. Nothing wrong with that as long as it works, right? That's why I was confused. Might be marked down. Yeah, I think it's all this. I don't think there's any other CSS in here except for that. And that's purely to generate documentation. I probably ought to get that out of here and like move it somewhere else, but yeah. But yeah, that's what that is. Okay. So, let's see. So ultimately what we want for our interface in terms of the asset system and being able to watch for a reload is we ultimately want something like this, right? Where we essentially call a function, we pass the asset system state, a pointer to the asset, which in this case there's nothing wrong with it being just a void pointer, right? We don't really care about the type. All we care about is the address. We can cast that to whatever we need as long as we know the type, right? And in our various types, right? We don't actually we don't have any sort of superstructure anymore that kind of contains all of this stuff, right? So we don't have any typing information that goes along with this, and that's by design, because it was kind of it was kind of annoying to have to kind of carry that around all the time. And so I'm thinking what we might actually need here is we do have this. So we have two ways that we can handle this. We could use the void pointer here with a type, right? So we could say kasset type, and then type, which is probably the way that we're going to go. You'll have to excuse my typing, by the way. I changed keyboards, so I'm still getting used to it. But this kasset type is just an enumeration that we've defined. I'm not even sure that we actually use all of these, right? But we could do it this way, where we say we watch for a hot reload, and then we just pass a type. The other way that we could do this is for each one of these types, we essentially add a hot reload function for that type, which might be a little bit better to do than having to pass this type and deal with void pointers, right? Maybe we call this underneath the hood, right? So maybe this becomes a static function, and we call that instead. And actually, the more I think about it, the more that's probably going to be the way to go. And I think that is I think that that's going to be the way we're going to go. All right, so that's how we're going to handle typing, right? We're going to keep kasset type. In fact, we're probably going to move key asset type maybe to something private. I haven't decided on that yet, but we don't. I don't necessarily want to have to pass this all around to sort of use that for casting purposes, right? I'd rather keep that internal if we can. So let's see. I guess let's rename this then. Let's do hot watch for reload internal, right? And that's going to wind up being static as well. And we'll probably wind up moving this to the bottom, right? So we basically want to say if state and asset, then we can proceed. Otherwise, return false, right? Oops. Caps lock. Hitting wrong keys tonight. All right, so maybe we just call this one, right? But the other thing that I haven't actually discussed here was something that we talked about a long time ago that we never actually wound up implementing. And that is, generally speaking, hot reloading is something that's great for debugging, right? But you never really need that in release. So when we're doing a release build, we should be completely eliminating the ability to do this, right? But we don't necessarily want to have to put ifs all over our code, right? To say if release do this, if not release do this. My thought is that we essentially set this up so that when we build release, all of this stuff just essentially gets if defed out, and isn't even compiled in the first place, right? So I think that that's probably the way to go. However, I don't necessarily only want to tie that to a debug build, because we might have other build definitions that we have in the future, and so I don't really necessarily want to do that. So what I want to do is head over to defines really quickly, because I think this was it here, or was it actually, it might have been the platform layer that we defined that. Yeah, we have Kohi debug and Kohi release, right? Depending on the compiler flags that we pass in when we build. So this is actually going to be probably the place that we want to do it. So feature, we can, I guess I hesitate to use the term feature flags, but I guess feature build flags, right? And instead of I think what we'll probably do is we'll say down here, we'll do if Kohi debug, Kohi debug, then we'll go ahead and say under that we'll do a define, and we'll say Kohi hot reload. And we'll set that to 1, right? And then we'll do else, and we'll do an endif down here, and we'll come up here and grab this guy and paste it here. And instead, we will go ahead and we'll set this guy to 0, right? So at least for now, this will give us hot reloading for debug builds, and it'll disable it for release builds. So we don't need to test that necessarily right now. I just kind of want to build everything with this in mind, and we can always test it later. So let's go ahead and copy that and head back to our code file. And I'm going to go ahead and paste that here. And we're going to just do a if Kohi hot reload, and then endif, right? And then that essentially will turn this into a no-op in the case of a non-debug build, or whatever we actually wind up using to flip this flag, right? So I'm going to actually take a copy of this, and I'm going to go to the top of the document, and let's see, not that far down. Let's go I guess, right here before all of our structure definitions. And I'm going to paste a copy of this, but what I'm going to do is take this and just do change to that, right? And so we've sort of forward declared that. And so that's kind of going to be the pattern that we follow, is anywhere that we have our hot reloading code, we're just going to wrap it in an if-def, and then that way during runtime we're not actually having to check that stuff. We could just go ahead and handle it as need be. Let's see. Let me catch up on chat. Any chance I can get a TLDR to understand why you're writing your own engine? Sure. So it's several-fold, actually. So I don't like how large the commercial engines are out there. You know, the big three, right? They contain a whole bunch of stuff I don't need. So that's one reason. Another reason is I like to have control over it, right? If I run into an issue, I like being able to quickly fix it and know where to be able to go to fix it. But the real reason I'm creating this is because there's not really anything out there that shows you how to build a game engine from file new, from scratch, all the way to building something that can be released and building something that you can actually release a game on, right? There's plenty of stuff out there otherwise, but there's not really anything out there that shows you the entire process from start to finish. So this was generally meant to be an educational resource. And it's a way to build a game engine, is what I always say. It's not the only way. It's not even necessarily always the right way. It is a way to build a game engine. We do experimentation on here. We try things. And have results where, they're good results or bad results. Sometimes things work, sometimes things don't. And we'll do a deep dive into why those things don't work. And we also go into, why we're making certain design decisions and the overall thought process that goes into making these things and all the various systems and how they tie together and everything. And so that was something that I would have loved to have when I was kind of learning how to do this stuff on my own. That never really existed and still kind of doesn't, right? And so that was the main goal with this. And so, that is why we created it, right? So we actually have this sort of portal here, which I'll drop a link in chat. And this is sort of the where you'll find a lot of information about the engine. So it kind of started off as a tutorial series. We outgrew that format rather quickly and had to, started kind of trying to mess around with other formats to figure out something that worked. Ultimately, we landed on the live stream format that you see here. So we do simulcast to YouTube and Twitch, but basically I wanted to create something that was open source. So it is free and open source. And it is cross-platform, so it runs on Windows, Linux, and Mac OS desktop environments. We have other platforms planned for the future, but that's what we support for right now. It's written in C and is using Vulkan as our initial rendering backend. We also do have plans to support Direct3D and Metal natively. And the reason for that is because I want to demonstrate how you might actually approach writing an engine where all of that render API code or graphics API code is completely abstracted from the rest of it, so that you can think about a design that might work with all of those things, right? And it's just kind of another design exercise that we're going through. And so there's that. And then on here, you can find a bunch of other stuff. We've got like a Discord with about 1,000 people in it, and our GitHub link here. Quickly point this out. So this is where the source code is. It is free and open source. It is Apache 2.0 license, which means you can use it either personally / indie, whatever you want to call it, or commercial if you want. Does not matter. The only thing that I ask is that you say you used it. The engine itself will always be free and open source. There will never be any sort of licensing fees or royalties of any kind ever. The games that I build on it may not be open source until after they're released, but those are closed source for right now. But the engine itself will wind up or will always be free and open source. So yeah, that's generally the shtick, as it were. Hope that makes sense. Okay. Then again, are hot reloads even needed on an engine level? So, there are two reasons that I'm doing it on an engine level, at the engine level, right? Well, I should say there's two separate concepts of hot reload. So, we have the concept of, let me actually pull up. We actually have the concept of asset manifest, right? And for lots of assets, it just gives the name and a path on disk, right? But for some assets, we actually have a name, a path, which is to the sort of imported asset, and then we have a source path, which is sort of a source asset. So in this case, a Kohi binary image, which is our proprietary image format that the runtime understands. And then we have a PNG that's a source. And we've got a utility that basically converts from this to this. So the engine only knows about this format, right? And so if we want to use this, then we are going to need to import that, right? So there is an import hot reload process that will happen here. And that will be powered by like an editor or something that's running. However, we also, for debugging purposes, or for things like shaders and whatnot, would be probably the best example. We want the ability to be able to hot reload that shader so that we don't have to shut down the engine and relaunch the engine just to see a shader change, right? Especially if we're tweaking values or something like that. And so we want the ability to very easily be able to hot reload that stuff. But we only want to do that in a sort of a debug build, right? And so that's the reason we might want that, is because it can be very useful for development. But outside of development, you really wouldn't want that, right? So I hope that makes sense. Wouldn't it be nicer to have a bool instead of 1 or 0, which is the same, I think? Yeah, I mean, we do have bool. We do have that. Yeah. It is absolutely pouring outside. Kuju, raiding with a party of 32. Sorry, I'm catching up on chat. How are you doing, Kujo? I hope you're doing well. Thank you so much for the raid. I think you guys actually had really good timing because I was actually just giving the spiel anyways on the engine. So thank you guys so much. Welcome, raiders. I hope you guys are doing well. Have a lot to do. We got to run. Fair enough. Thank you so much for the raid, Kujo. I really appreciate that. If you guys aren't familiar with Kujo, he is making a game called Fat Goblins. He is also writing his own game engine in Jai. So I highly recommend you guys go check that out. It's a fantastic looking game. He's really made some excellent progress on it recently. So yeah, definitely go check that out. Let's see. So it's more like a base where you could build up on rather than rendering options. This sounds really fun. Yeah, exactly. So it's, we kind of build on top of it. Do you have any advice for finding a junior SWE job? I would say it depends. And the reason I say that is it depends on what kind of company you want to get into, right? Some companies love, leak code questions. So if you're wanting to go for like a FANG interview or something like that, you're going to have to study up on your leak code, which I think is really stupid. It's not a good caliber for how good you are at actually writing things, but yeah. If you're wanting to shoot for one of those companies, that's something you're going to have to do. The biggest thing that I can say that you need to do is always be writing code to, hone your skills and get better at it. Figure out where you want to work, what technologies those places use, and learn those things. And be a self-starter. Don't wait for somebody to hand the stuff to you. Learn how to learn on your own, and then use that to, enhance your skills. Because I promise you, if you do that, you will thank yourself later on. And picking up new things will be a lot easier for you. So I hope that helps. Hamlet, how's it going? Good to see you. As usual, coming from Java to C game dev, I'm struggling with memory allocation. Read some of the cool techniques like bump allocator, arena allocator, or do some sort of allocate and free call all over the place. Just wondering how you do it. So we have a couple of allocators that we use. So I have one that essentially, I call it a dynamic allocator in this case. That is, it grabs a huge block of memory and then doles that out. And so we essentially have our own version of malloc, but it pulls from that already allocated block of memory, right? So you're not having to constantly reach and ping the OS for more memory. So we have that, and then we sub-allocate portions within that to other allocators, depending on what kind of allocation we need to do. So, I've got a linear allocator, which just moves a pointer along, and I've got the dynamic allocator, which has a free list internally that I manage, to track allocations. A good use for the linear allocator is what we use it for is a per frame allocator, or a frame allocator as we call it. And that is where you have where you need allocations done in the context in the middle of a frame, and you need them to be fast. And that is, a linear allocator is about the fastest allocator you can have. It has almost no overhead. And so we use it for that, and then that gets reset every frame. But yeah, that's kind of a short answer, but that's essentially how we handle it. Do you have any specifics on why you're removing the render graph? I vaguely remember you saying it was hard to use. Is that a result of the implementation API, or do you think render graphs were just the wrong way to go? I've never tried them and am currently happy with my Uber shader bindless approach, but was thinking of checking them out. So I'm not completely unhappy with it, right? It's a little cumbersome, and we could fix that. But what the real reason was, it was an exploratory thing, right? But the real answer to it is it's just unnecessary overhead. Because when you stop and think about it, the application that you're building on top of the engine knows how things need to be rendered. And so, if the application wants to make something generic like that, then fine, I suppose it maybe makes sense, but probably not. But the application knows what order things need to be, knows how to grab the data, it knows, all of the parameters that need to be passed. You don't need this big generic thing sitting on top of your renderer to actually do that for you. You can actually just make the calls. You can eliminate a lot of overhead like that, right? So it was like something generic that we tried, and it's cool and it does work. But it's overhead, right? It's overhead both in terms of the amount of code that it takes, the mental overhead of maintaining it, as well as the actual performance overhead that's incurred by actually maintaining that, right? So yeah, that's generally my reasons, right? Leak code interviews ain't great. No, they are not. I am not a fan of them. But, they are a reality, unfortunately. Don't have a particular company I'm interested in as long as I can do fun or interesting stuff. That's fair. But what I will say is this, especially if you're just starting in the industry. The problem with doing fun and interesting is that it either A, doesn't pay well, or B, you have to work crazy, crazy hours. If you go into something like game development, right? It's great. It's lots of fun. But it tends to, come with the cost of overtime, right? Lots of it. And so what I usually recommend to people, especially just starting in the industry, is just get something to pay the bills and do the fun stuff on the side, right? Because generally speaking, if you go into something like that, you'll get a better paycheck. You won't have to work as hard, that kind of thing. But that being said, it heavily depends on what you want to get into. That is absolutely not true if you want to get into game engine development for a major company, right? In that case, you can't do that. You have to shoot for those jobs, right? If you want to get into something that's super specialized, like embedded, right? That's like another thing. You have to shoot for those jobs. So it really depends, again, on what you want to do. And you've got to kind of figure that out. I would say try some stuff on your own to figure out what you want to do if you don't really know. But yeah, you do want to take a minute and kind of weigh out, how much overtime and how much, really hard type of work do you really want to get into right off the bat? Work-life balance, all those things. That tends to be a little bit less important when you're younger, but it gets important as you age, right? Hope that makes sense. Probably much easier to find any company you know what you're interested in, depending on what it is. Yeah, it depends on what it is. Let's see. I'm just going to have to kind of bounce forward a little bit. Frying Walk, how's it going? First time chatter, welcome. Hot Reloading Gang, yes, we are working on hot reloading. As soon as I get back to actually coding. I do see you guys over on the YouTube side. I'll get to you in a second. I've been working in tech 5 years now as a consultant, and I agree. I've been in projects that are really slow, like working for pharma. But when I started working on bigger companies with crazier projects, I even have to spend weekends for months working. Yeah, that can happen for sure. Yeah, for sure. All right, over on the YouTube side, Jeet, how's it going? Good to see you. Hypnotic Chris? Wait. Yeah, I did pronounce that right. How's it going? Good to see you. His game is called Fat Goblins. Yours was called Goblins Who Steal Hats. Nice. Singy, good to see you as well over there on the YouTube side. I hope you're doing well. Good to see you, bud. All right. I'm going to get back to some coding. So this is essentially the pattern that we're going to follow in much of our code base when we're actually figuring out how to go ahead and handle our hot reloading, right? Because we don't want to necessarily have that all over the place when we are building out our release builds, right? So I'm probably going to go ahead and just put this right here. So we're going to have one of these for each type is the way we're going to handle types, right? So we're going to say this is not going to be static. We're going to say watch for, let's actually do asset system, watch, let's just say watch binary. Right, and then we'll have like watch text, etc. Right, so we'll have state that we'll take for that. We don't need the asset type, and then of course we'll have k asset binary, right? And so essentially, what this is going to do is this is going to just be a pass through to our return. Watch for reload internal, right? That's going to pass the state, and then the k asset type in this case is going to be binary, right? And then keep hitting the wrong keys, and then for the asset, we're just going to pass the asset, right? And then that is going to be essentially the way that all of these are going to work. So we've got sort of a type safe version of this that sort of wraps the void pointer internal version of it. So the nice part about that is we don't have to worry about, doing all this typecasting and stuff externally, right? And so when we call this, this is what's actually going to handle all of the internal logic in terms of getting things kicked off for the correct asset type and things like that. So let's see. What we want to do is we essentially have, let's see, how should we, we're also going to have to have some sort of event handler for each one of these asset types, right? And for things like binary assets, it's going to be really, really easy, right? It's essentially going to be a synchronous operation too. We're not going to do asynchronous with this because I don't think that makes sense. So in the case of a binary asset, the only thing we have to worry about is the size and the content, right? So that's not really a big deal. We can just pull that from the VFS asset data when we're done. But before we can even do that, we actually need to take a look at our VFS and modify it to actually fire off a message that we can use in the first place. So before we do that, we have to go over to event H, and we need to go to our event listing here. Do we already have, I forget if we already have any sort of hot reloading. Here we go. So, okay, so we have asset hot reloaded, asset deleted from disk. Okay, so we need to change these up a little bit. And then we also need, we're going to need one more, which I'm just going to paste this here for right now, and then do an endif, and we'll come back to that in a second. All right, so what we're really dealing with here is we do want the asset hot reloaded, so I suppose we could leave this one. Although, let's see, this one sends a watch ID along with it as its context. I think we can probably keep this one as is. No, we can't keep that one as is. We need to actually change that one because we need a little bit more information than that. So this is the message that is going to be fired off after we've already processed the asset, right? So there's two steps here. Whenever a write to a file on disk happens, we're notified from the file system that that has happened. When that occurs, we then need to reread that entire file. Once we've done that, at that point, we then can take that and pass it to the asset system along with the type. The asset system can then pick that up and say, okay, process this asset data for this specific type. And at that point, then we would call this and pass along a pointer to the asset so that we have it. Well, actually, I guess we wouldn't. Yeah, we should probably pass a pointer to the asset so we don't have to retrieve it by other means. And then we could also pass the file watch ID, right? And the watch ID is what we're going to use internally in the systems to kind of look this stuff up. So, okay, so we'll say an event fired from the asset system when a watched asset has been read to. Now, the context up here. So this is our event context that we can send along with an event that's been fired, right? So we have this massive union here, which is our data, right? So it can either be an array of like various number types, or it can be, size and data. So we can actually use a custom data here, or we can pass a string. So we're going to want to make use of this custom data. And probably what we're going to do is have some sort of structure that contains both the file ID and also contains the pointer to the asset, right? And then we'll sort of unwrap that on the other side of the function. So what we really need here is a change to our definition, right? So we want to actually say context data custom data, right? And this is going to wind up being, instead of a U32, this is going to wind up being, it's going to be a, I guess we'll say a K asset reload context, right? And that's just going to be a struct. I guess we'll just call it a struct. And so we'll put this here in the comments, right? Just so that we actually know what that is. Oh, I guess we could, we were saying the K asset pointer is the sender though. You know what? I actually like that a lot better. I'm going to keep the old system. Let's do that. Because that does give us both pieces of data without having to use the custom data thing and having to perform an allocation. I actually like that better. Yeah. I had forgotten that we were doing this part. Okay. So that's asset hot reloaded, right? So that's after the asset system has processed the asset and it's ready to actually be used. If it's a texture, its pixel data has been loaded and it's ready to be uploaded to, the GPU, for example. The thing that we do need to change is going to be this asset deleted from disk. So what we really want here is event code VFS file deleted from disk, right? And this is going to be when a watched file has been removed from disk, right? And it looks like we actually pass along the VFS asset data as the sender, and then a watch ID with that as well. So that is good. And then we also need something which I'm actually going to put above here. And I'm actually going to rename this one to, or I'm going to change that one to 25, right? And then we're going to say, VFS file written to disk, right? And so this is going to be fired when a watched file has been written to disk, right? And so this should hopefully make the two layers of it a little bit more understandable, right? So VFS file watches and all that stuff. I tend to think that we probably should not support that at runtime. Right, so I think what I'm going to do is just take this and move it up here. Right, and so these things are only supported when hot reload is true. Otherwise, these events don't exist. Right, and so if we try to compile code with this in release, right, it won't work, which is by design. So that's one way that we can kind of catch ourselves with that. All right, so that's the event. Let's see, U32, watch ID. Okay, I've got all of those set up, so that's good. Now I guess we'll have to go to actually the VFS. And VFS has got a couple things that we need to change as well. This is one of our bullet points here, right? So our VFS has watch for hot reload and file watch ID that gets passed along with VFS asset data. I don't think we should be passing this stuff. I think that we can do a little bit better than that, right? So let's just take a look at the way that this works. So we have on asset loaded callback, we have this hot reloaded callback, we have this deleted callback. These are going to go bye-bye. We don't want those. Because that is just not something, that's not the way we want this to work, right? So whenever we hot reload a disk, or whenever we hot reload, right, we're going to be passing, we're going to be firing off an event that already contains this in its context, right? And then contains this as its sender. And then this Boolean watch for hot reload, like I don't remember our purpose for passing that, but we don't really need to do that. So we can get rid of that. And then we have, for our VFS state here, we have our callbacks for like hot reloaded callback, deleted listener, hot reload listener. Like we don't need any of this crap now. All we need is, let's see, watched assets, which actually, I'm not even convinced we actually need to keep this here. Right? We can keep that at the, asset system level. So VFS request info, this is the other thing that we need to clean up a little bit. So we have this VFS callback for asset loaded callback. Oh, wait a minute. I might have nuked a, yeah, these are the two. I need that one still. Okay. So we're going to get rid of all this. And we're going to get rid of this. And then we catch up with chat here. Why is VFS involved in here? What do you mean? What do you mean by that? Apotham, good to see you. Welcome. How are you doing? Looking at those comments, I really need to learn how to write proper comments. Yeah, I mean, this is one of the most public-facing parts of the engine, right? So it needs to be right. What are you using it for? Okay, so just to kind of give you an idea of the way that this whole thing is organized. We have a VFS, right, which is Virtual File System. That's what that stands for. So that sits on top of a packaging system that we have. The packaging system is what we use to group assets together. The packaging system uses the file system directly to indicate, or to load things off disk, right? But there's two modes of it. So there's sort of the debug mode, which loads directly from disk. And then there's going to be a release mode where we can actually build a package into a large binary blob. And the K-package system will be responsible for reading that as well, right? So it can read either way. Hot reloading is only supported in file read mode, right? So the VFS sits on top of the package system, and it manages the packages, right? Manages the packages, their manifests, all that stuff. So whenever we request something from the VFS, we request it by package and asset name, right? And then there's some other things here in terms of how it actually gets loaded, which we'll come back to in a second. And actually, there's some things that I see here that we also need to get rid of and simplify. And so the VFS is a very thin layer, right? And it's also, up to this point, has been responsible for telling the file system to watch for, asset file updates, right? Or deletes or things like that. And so the asset system then sits on top of the VFS and communicates with it, right? And so that's kind of the split up there, if that makes sense. Does package size matter? No, it does not. I'm doing good. Thank you for asking. Appreciate that. Luna Moon, welcome. So right now I am working on asset hot reloading. And what that means is basically that whenever you upload whenever you update an asset on disk, say an image, that we have a way to say while the application's running, we say, hey, this image has been updated, reload the texture. And that's useful for a lot of reasons when you're building a game, right? So yeah. Interesting, forgot about packaging in games. Is the VFS still used in release mode without hot reloading? I mean, yes. Yeah, so the VFS still uses the packaging system, right? It's just instead of the packaging system reading all those files from disk, it has a massive binary file that it reads with a lookup table that has byte offsets and stuff internally. And that's the way that works. That's the idea. All right, let's see. Pixel Checksum, how's it going? Welcome. Can you VFS both Linux and Windows? Yes. Yeah, the VFS works cross-platform. Yeah, it's platform agnostic. Okay. So whenever we request something from the VFS, this is our structure that we have to fill out to fulfill the request, right? So we have a couple things we need, like package name, what package we're pulling from, the name of the asset that we're requesting, whether or not it's a binary asset, and then whether or not it's a source asset. So there's a lot of things in here that don't necessarily apply before, because we used to have our import system in our runtime, and we don't anymore. So the concept of a source asset in a VFS request no longer exists. So we actually don't need that anymore. And then watch for hot reload is also not going to happen here. And that is because whenever we make a request, we're not going to worry about hot reloading at this point. If we want a hot reload, we'll go ahead and request that separately once we have the pointer to the asset. Context size and context, we do want to keep those things. Those are important for this callback right here because it's essentially a way to pass through data. The other thing is we have these import params and import param size. We don't need those anymore either because we don't import assets this way anymore. We've got a separate pipeline for that, so we can actually simplify this. So this is much, much simpler than it used to be, which is great. All right, let's see. Is there anything? There's going to be a couple things here that we need to get rid of. So we have this hot reload callbacks register. So this was what would, register our hot reload listener, our hot reloaded callback, our delete listener, our delete callback. This whole thing can go. We don't need that anymore. We're not going to do it that way anymore. It's going to be simply using our event system, which we already have in place. So I think that might actually be all that we have to delete, I believe. But what we do need is we do need a way to tell the VFS, hey, we need to actually watch for reloads of a particular asset, right? So the way that this needs to work is, let's see, we need a U32. That's going to be the watch ID that we return. We need VFS watch. I guess we should say VFS asset watch for, I guess just watch, right? VFS asset watch. VFS, actually, yeah, we need the state, right? So we need state. And then, let's see, we're probably going to need asset name and package name again, because that's what's going to give us the path that we need, right? So kname, asset name, kname, package name. So we're going to have to think about that a little bit on the upper levels to see how we can, possibly manage that a little bit better. So that is all we should need to do at this level, is just essentially fill that function out. So I'm just going to go to definition on this guy, and we're going to define that real quick just to kind of get an idea of what that is going to look like, and then go from there. Let's see. Okay, package. Asset watch. There we go. So let's see. That needs the asset path and then the out watch ID. So we need to get the package, first of all, from the package name. And then we need to get the asset path, and then we can output the watch ID. So we'll need to get all of those things. Thank you for the follow. Appreciate that. Are you going to be streaming every day? Unfortunately, I cannot, because I do have a full-time job. But I am streaming tonight, and I will be streaming tomorrow night as well. Thank you for the hydrate redeem. Appreciate that. I do have water here. And thank you for the follow. Appreciate that. Let's see. Can I ask a question out of the stream context? Sure, but depending on what it is, I may or may not be able to answer it. But go for it. I'll do my best. All right. So I think, let's see. So packages. I don't think we did we ever do a lookup table in this? I don't remember if we did. Trying to remember because it's been a bit. Yeah, we don't have that. Okay, we just do it the hard way, which is not really a huge issue because this isn't called all that often. So let's see, package count. Package count is actually also going to be the array length, so I need that as well. All right. Okay, so here we have the package, right? So we can actually move this up here. And whoops. Let's delete that. And then we can do kpackage let's see. We want path for asset, right? So we want to pass package and then asset name, right? And I believe that is a dynamic allocation. Turns a copy of the path string if found, otherwise 0 null. I think. Let me just make sure before I... Yeah, we do a string duplicate. All right, perfect. Okay, so we just need to go here and we'll say constant character array, and we'll do asset path, right? So we can use the k package to grab the path for the asset, right? And then we say k package asset watch. We already have the package. We already have the asset path. And now we just need to output the watch ID. So u32 out watch ID. And we'll just say equals invalid ID u32 by default. And then we want the address of out watch ID. And I believe this returns true on success. And it fails on, yeah, okay, all right. So if it fails, it returns false. Okay, so I guess what we could do, let's move this. Let's hoist this up here, right? Because we're going to need to return something for this. And returning out watch ID as invalid u32 is basically saying, hey, we couldn't watch this file, which I think is fine. So don't really need to check the Boolean on this because if it fails, out watch ID would not have been updated. So here we can just do break. And then down here, we can just return out watch ID. Whoops, forgot a semicolon here. Is that right? Yeah, okay. So VFS Asset Watch basically just works that way. It's pretty straightforward stuff, actually, I think. Not a whole lot to consider there. I do want to take a look at the state really quickly and make sure that there isn't anything else that we missed. Let's see, VFS asset data. We do have these two things. We did want to get rid of those. We don't need those. And you'll notice that a lot of that stuff isn't used because we don't get any errors. Let's check K package real quick just to see. We don't have any errors in here either, so we are good. All right. So, platform watch file. Let's see. This. Let's see, we have the outwatch ID, and I believe if you're wondering how this actually works under the hood, here is the Linux layer, because that's what we're on currently. We do have a number of watches here at the platform layer. I think all we do I'm just trying to remember how this actually kicks off, because I haven't looked at this code in probably 2 years. Unregistered watch. Update watches. This is what it was. This is what I was looking for. Okay, so watcher deleted, callback, and then watcher written callback. And that's at the platform layer. So we must be setting this somewhere. Platform, file watcher, file written callback. So there's all the platform. Do we actually not call this anywhere? Really? I must have nuked that somehow. So platform register. Register watcher. Written. Oh, there it is. It is in the VFS. Okay, I did register it. All right. Okay, so let's go to here and examine this. Yeah, that's what I thought. Okay. All right, so the VFS does need some changes. Nothing huge. This is because our old model basically had a callback model that it was using. And so we're not going to be doing that anymore. We're just going to fire off a message, right? An event, rather. So I think what we're going to want to do is right here. We're going to want to say event context. Okay, and we're going to fill that out. We're going to say data. And we'll do U32 equals, let's see, watcher ID. And that's all we need to do for that. Actually, it needs to be U32 sub 0, because that is an array. So we have a context, and then we can do event fire. The code that we're going to want to use is event code VFS, and this is the deleted callback, right? So we want to use deleted from disk. The sender, I think we said was going to be the asset data in this case, and then we pass the context, and that is that, right? We fire that. We don't need that, and then so the asset data, watched assets. Oh, right. We're not watching assets at this level anymore, are we? Okay. Okay, so watcher ID. How do we get the... Oh, there is no asset data for delete. Actually. Did we update the... Yeah, we didn't update the comment to reflect that. No asset data is included, obviously. Right, we're deleting it. We don't have that. So we don't actually even need to do this loop. We don't even need any of this, right? We can actually just do there's a to-do there. Let me address that in a second. We don't need this check either, right? So event context, oh, okay. Let's just do EVT context. Right, because we don't EVT context. Okay, so asset data was the sender. We don't have a sender anymore, so this is actually going to wind up being 0. Right? All right. So let's see what else. asset data package name. At this point, we don't actually know. We don't know what asset was actually deleted. So we should probably have some way of actually telling that, right? So I'm thinking when we go to cache this, we probably need to store the asset name, the package name, pointer to the asset. And that's probably about it. And then the lookup will be the watcher ID. Let's see. Let me catch up on chats. I was hoping I could watch your stream for motivation. Well, I mean, this is episode, 282, right? So if you wanted to catch previous streams and previous episodes, it's definitely there. If you go check my YouTube channel, there's a playlist with like all of the videos, right? Internal static void, how you doing? Did you ever end up trying out GDB? So actually, because I've been so busy with like IRL stuff this last week, I was not able to touch this project at all since the last time I shut off the stream. So no. It's on my list of to-dos. I just haven't been able to get to it. Been crazy busy outside of it. But yeah, it's definitely on my to-do list, right? Because I do want to get away from having to use the editor that shall not be named to debug. What is your full-time job? So I do work as a senior software engineer at Oracle at the moment. So, okay. So this indicates a problem that we don't know. We don't know when we actually watch an asset. We're actually going to need that for here too. We're going to need to know a little bit of info about the asset that we're watching, I guess. Unless we treat it purely as a pass-through and don't worry about that stuff. Which maybe is a better... Maybe that's a better thing anyways. Let's try it with that in mind. Because I really don't want to track file watches at this level. And actually, I don't even need state here. Okay, so let's do, for this, here we're actually just doing, let's see, asset data. We were maintaining a pointer to the asset data before, the VFS asset data, which actually is not necessary because it looks like all we were doing here is literally just we're freeing the old data and then rereading the new data, which is something that we need to do. But we don't need to actually keep it. So we can actually just, I think, allocate a new one. We can allocate a new VFS asset data and pass that through. So I think we can literally just do this. Let's see. I guess we should probably... The reason I say allocate a new instead of doing it on the stack. Well, I suppose if we fire the event will just take... If we're passing this as a sender, it's got to be a live pointer. Because an event can take more than one frame to actually do its thing. So, yeah, let's just go ahead. We'll be safe about it. So we'll do kallocate. Or actually, let's do chaotic type, right? The type is going to be VFS asset data, and the memory tag is going to just be asset, right? The only drawback to this is that we are going to have to clean this up somehow so that we don't leak that memory, which I don't like. Let me think about this for a second. Is this called immediately, or is it... No, it is called immediately. So there's never, unless we jobify this, which I don't think I'm ever going to do. Yeah, I guess we don't really need to do that. Okay. Yeah, on the stack is fine. I really don't want to deal with this. Okay, so let's do this. And we're going to say we need this here, right? So we need let me think. So we have a watcher ID. So we need the asset path for that, whether or not it's binary. Context. Do we need a context for this? I don't think. Asset data context size. I'm trying to think if we would actually need context for any of this. The only time that's ever really needed is for asynchronous stuff, which we're doing this synchronously. So I don't think we actually need that. I'm going to pass that as 0. And I'm also going to do, instead of asset data context, which we don't have, that's going to be 0. And then asset data. What is this saying? This is out data. What are we passing? So we have asset data here, which is from that. So this essentially fills out the asset data. So we could move this here, 0 that out, and then let it be filled in. What else do we need, though? We need a couple things on there, though, I feel like. So we need path is binary. Actually, that's it. So we need to get those from somewhere. Then we read the asset from disk. That goes here to asset data. And then from here we do a event context contexts. The data U32 sub 0 is the watcher ID. And then event fire is going to be event code asset, VFS file written to disk, right? The sender is going to be the address of asset data. And then we pass the context, the event context rather. And that's essentially going to be the whole function. So we don't need all of this stuff. That all can go away. So that could be removed. And this is return type void, so we don't need to worry about any of that other stuff. So really the only problem is is whenever we get a watcher written, we have the watcher ID that's passed. I suppose, aren't we keeping track of this at the platform level anyways? We probably could modify the platform code, which probably knows the path of the asset to begin with, or the file on disk. If it knows that and whether or not it's binary, we could very easily pass that through in this. And then that would solve all our problems, and we wouldn't have to be doing a bunch of tracking all over the place. So let me go to go back to Platform Linux, right? And watcher written callback, where it calls it. Let's see, we have, here's the file entry right here. So, yeah, we already have this right here, right? So we have the Linux file watch, right? And this will be the same on Windows and Mac OS as well. We already have this here. And so we could very easily add in here is binary, right? And then wherever we have this, register watch, which is internal. Let's see, do we have platform watch file? And we basically just say, watch this file, right? And then return a watch ID. So we could, anywhere we call platform watch file, we could very easily, because I think we probably only call that from one or two different places. Kpackage asset watch. Oh, okay, so we'd have to change that at the package level as well. That's the function definition. Game code calls it once. But basically anywhere where we're calling platform watch file, we're going to know whether or not that file is a binary file. So I think if we pass it through at this level, then we can pass it down to the platform layer. And then we have everything we need when we go to pass out or fire off that event. I think that makes sense. All right, so let's do that. Let's go to the header file. So let's see, we have the asset path. So we'll do a B8 is binary, right? And then we'll go back and we'll do here is binary, right? And then when we do platform watch file, that is going to be B8 is binary, right? Which we actually need to do is binary indicates if the file being watched is binary. If not, then text. Okay. And then in each of the platform layers, we'll just have to modify this is binary, and then register watch binary. Let's see, register watch. Is binary. And don't we have that declared at the top somewhere? I thought we did, maybe not. Okay, so in VFS, we're actually, where we do the asset watch, this is also going to need to know that, right? So we can do B8 is binary. And then we can pass that down, is binary. Right. So we have this at the end. B8 is binary. Okay. So that passes that down. So now, this callback, for the written callback, we're going to change the definition of that a bit. It's going to be the watcher ID, file path, B8 is binary. Right, we're going to take that and go to here. And now we'll have file path and is binary. And then let's see, what is this? I think, does this want a pointer to that? Yes. So we want the address of asset data. Perfect. All right. So that gives us everything we need there. I believe. Yeah, that makes sense. All right. Again, literally ruined every other debugger for me. Yeah, that's what I've heard. A word I applied at Oracle, but I think their AI system flagged me when I didn't have college, but I have 5 years experience. Might have been. Can you imagine how many applications they get though? Like I can only imagine. Like they have 170,000 employees. So, yeah. It's kind of crazy. Yeah, it's got to be insane. I don't blame them either, for sure. You don't use a debugger? I do. I use the debugger that shall not be named. Also known as VS. Not the right one, yeah. The reason I've used this one, the reason I've used this one in the past is because I can use the same setup on Windows, Linux, or Mac, which is really what's kept me from using GDB, because right when I switch to Windows, then I can't use GDB, which sucks. Yeah, you know, Arvis, it is what it is, you know. Windows has WinDebug. Yes, that's true. I don't know if it's exactly the same interface-wise, though, right? I've never tried it, though. Debugger needs to be a visual GUI, otherwise it's pain. Yeah, I mean, that's kind of the way I've always felt, and I don't feel that way about a lot of things, but I feel that way about a debugger. So, it's going to take a lot to change my mind, but also at the same time, I try to pride myself on trying new things and not just being stubborn, right? GDB slaps. Yeah. I don't know why it flagged that. I'm gonna allow it. Um, hard disagree. Yeah, it's funny. Like I used to say the same thing about IDEs a long time ago until I found this. Right. So we'll see. Um, let's see. Let me catch up on chat over on the YouTube side. Want to switch to Linux, and over Wine it won't work, so I'm wondering which is the nearest, like, AutoIt lang I can learn. Basic, free basic, Pascal, I have no clue. I guess the answer is Python because there's modules, right? Native's not your native language. Nah, don't worry about that. If English isn't your native language, you're doing just fine. Um, so usually, I tell people at some point in their programming career, even if they don't stick with it, that they should learn C because it makes learning other languages so much easier. Even if you don't stick with it, you should at least know it and get good with it because it opens your mind to a whole bunch of other things that other languages do for you. This is C. Yep, this is all C. I fell into abstraction hell. Yeah, we've done that a couple times here. I'm trying to get out of it, actually. Do you maintain a scene graph? I know that GLTF files preserve the scene graph, so do you end up storing the node hierarchy with the asset data? So right now we do kind of have that. We're going to be reworking that as well, but what we have right now is a scene that has several views. So it has like a hierarchy view, which is kind of what you might think of as your scene graph. It's got a few different ways of accessing that data. And I think that that's the right approach, but there are some things in terms of the way that the data is actually stored that I want to change. So ordinarily speaking, I would say you should probably avoid like a deep nested object-oriented programming way of nesting classes or structures or creating a tree of structs or with pointers to other things and things like that. I would avoid that, and I would make a hierarchy graph, which is essentially what we have. That is a single view of the scene, but not the actual representation of how the data is stored. So essentially, we have something called we have nodes that have attachments, and each of those things are stored in flat arrays, and then they're accessed by index. And so our views reference those things by index. And the same goes true for transforms. There are some aspects of it that I want to simplify, but that's the basic idea. Let's see. Setting a breakpoint through a GUI by clicking the line of code directly should be better than a command line at least. I mean, maybe. Again, I haven't tried it, so I can't knock it. One of those things where how powerful it is outweighs how hard it is to use. Yeah, that's probably true. I certainly learned that lesson with Vim. So, yeah. All right, so we have watched assets. We no longer need this at the VFS level. That is stored, or that is already done for us at the platform layer, so we don't need it watched again. Which means all the stuff surrounding that can come out. So VFS watcher written callback, that needs to be updated. Did we update it here? I don't think we actually updated the type def for that. So I'm going to put this here, right? And essentially, this is going to be type def, and then we need void, and then this is going to wind up being platform file watcher, and then we'll do file written callback. right? So it matches the name, and we don't have to sit there and like change the entire thing, right? So we could just do that. Oops, did we not? Yeah. Okay. All right, so let's go back. There we go. May actually give it a chance and learn it properly. Rad Debugger sounds promising once I get out of alpha and support Linux. Yeah. And Rad Debugger does look awesome, right? But knowing Ryan, he's probably not going to support macOS, which just kind of kills it for me. So yeah, I don't know. It really does look awesome, and I think we do need more competition in that space. So I think it's really awesome what he's doing. I wonder how he's going to handle that. I support macOS dying. Yeah, not going to happen. Not going to happen. And I don't think it should either, because I think, again, we need somebody besides just Microsoft out there, right? I'm not saying that what they're doing is perfect, right? But put it this way. In terms of operating systems I would use, I would take macOS any day over Windows. Any day. Windows is that bad lately. Okay, so hot reload callbacks register. I think we get rid of this on the... Yeah, we did get rid of this in the header, so we just need to get rid of this here. All right, so that's some more of the errors. Let's see, what do we have here? VFS asset job success. Okay, so this is when... Okay, VFS asset job success. Okay, so this is only going to happen this is only going to get called when we asynchronously load an asset, which we're never going to asynchronously hot reload an asset. We're just making that a hard and fast rule because that just complicates everything for no reason. So if it's a hot reload, it's just going to take a second. It is what it is. Let's see. So we were doing cleanup context and import params if not watching. So that means we need to do it all the time. Right? And actually we don't need the import params either. Thank you for the follow. Appreciate that. McGats, how's it going? I take 2018 era Win 10 over Mac OS. Yeah, I don't even know about Windows 10, to be honest. I mean, Windows 10 was okay. But yeah, they started going in a crappy direction even then. But yeah, I guess 2018 era was okay. Pre-AI for sure. Okay, so result data. This is VFS asset data. I thought we removed import params. We did not, apparently. All right, let's get that out of the VFS asset data. We don't need that, which means all this can go. More deleted code. Love it. Okay. So, all this import stuff, which is cool, that can go. All right. The next thing, and this is because of something that we deleted here, this get source. We don't get source assets anymore. We don't do that. So kpackage asset bytes get. This is something we need to phase out, actually. We don't need source asset data anymore. In fact, we do have some results around that, right? So we have primary get failure and source get failure. So we don't need source because we don't have source assets at this level anymore. We're going to say kpackage result asset get failure is what we're going to rename it to. And I did not do the refactory name because I want all of the errors to show up. So kpackage result asset get failure. Oh, we don't want get source anymore, actually. So let's actually, let's see. Let's get rid of get source. We don't do that anymore. So all we're going to do is just return that, and we don't have anything else, right? Okay, so validate asset path. Let's see. Asset path is going to be entry. An entry, I think, is an asset entry. Now, I should point out that in our asset entry for a kpackage, this is what is read in by our asset manifest. We do want to keep source and path, right? Because we do use this for external utilities as well. So we do want to keep it at this level, even though we're not going to actually use it in the runtime code. So what we really want to do here is we don't want to do get source. We just want entry path, right? Let's see, package, no asset path exists for asset. And then again, we don't actually need this string anymore. Actually, we can actually just say no path, whoops. No path exists for asset, right? So we don't need this string, we don't need this string, we just need the name string there. And so, let's see, this is going to be, what error code do we want to return here? So we want primary get failure. In fact, this is going to be asset get failure, right? Because there is no primary as far as this knows. Okay, so this is going to be the same thing. Invalid path for asset, right? So we just need path and the name of the asset. Again, we don't need this to be conditional. This just needs to be asset get failure. And then this is going to wind up being the same thing. Package, let's see, package name. Okay, so this we just have to worry about the code. All right, asset get failure. I had forgotten about this level of it. It's good to actually be going through here and deleting so much code. I love it. Okay. Let's go to the next error. All right, so asset get data. This is now expecting a get source, and that no longer exists. Now, in the kpackage asset bytes get, that one and the text both have a get source. We don't need that anymore. We can get rid of it from that level. And then from here, we can get rid of it at this level, and then at this level, and then let's see, get source, we don't need that anymore, and then we don't need it at this level. And then the asset watch, let's see, we need the asset path and the is binary at that level. Let's see, watch ID. Didn't we? Oh, I already had asset path in there. What a dingus. Okay. Cool. All right, so that actually solves K-package. So let's go back to the VFS where we can simplify stuff here because we don't have info get source anymore, right? So we can delete that and we can delete that here. And then, oh, VFS asset flag from source. That we don't need anymore. All right, so we can completely remove that code. And then this is going to be asset get failure, right? And that's going to be result file doesn't exist. Source get failure, VFS request result does not exist. Let me delete this line for a second and go here because this no longer makes sense either. Right, so we can delete that. Let's see. Okay, so if get source. So if we're getting source, we call kpackage source path for asset. So in this case, I think I am going to leave that function, like this this function here. I think I am going to leave that there in terms of it actually existing, but like we're going to eliminate the call to it. And then outdata source asset path is going to be removed, I think. VFS asset data, or we're just not going to set it. No, we're not going to actually include that in VFS asset data. We don't need it at this level. Don't want it. All right, so we can eliminate that. We can eliminate the get source branch and eliminate that. Okay. So when we request the asset, okay. So we used to do this all in kind of one step. Like if we had hot reloading flagged for that particular request, then we would do it here. That's completely a separate operation now. So we're not going to do that there either. There's only one way that we can actually watch stuff now, which is much easier to deal with. Jobify this call. Yeah, I don't know that we're going to do that anytime soon. I'm not too worried about it. Okay, so we have that. So then we need to go back to the asset system. And we need to watch for reload internal, and we need to actually hook this up, right? So here we actually have the asset type. So we can tell from the asset type whether or not it's going to be a binary asset. And then we also have a pointer to the asset, but we do not have... I think the only thing that we're missing is actually the path. So I think when we go to call the watch for reload, we think when we go to call the watch for reload, what we really need to do, thinking about this now, when we are, did I actually put this in here even yet? I don't know if I did. I guess I didn't yet. Okay. I thought I'd added it to... I thought I added it to here, but I guess I didn't. I thought I added it to the header, rather. All right, so when we watch for binary asset, we need to provide a pointer to the asset, but let's see. This only has the size and the content, right? So for this one, we're going to have to say kname asset name. Whoops. Kname package name, which whenever we are hot reloading or watching for a hot reload or requesting an asset or any of that stuff, we should have those things anyway. So I don't expect that that's going to be much of an issue. So what we can do here is asset type. We'll do kname, asset name, kname, package name. And then we'll have to do the same thing here. I probably should just copy that, but whatever. Kname, asset name, kname, package name. Right? And now we'll have everything that we need to actually do the thing. Let me see. We also have to pass that through here. So we'll have to say asset name, package name. Okay. So, request a file watch from the VFS and return the file watch ID. So I think we can just do U32 file watch ID equals VFS asset watch, right? And then we'll do engine systems get VFS system state, and then we can do kname, asset name, which is already provided, package name, and then binary we'll have to figure out based off the asset type. So I suppose, actually, I suppose we would know that too. You know what? Instead of having logic to determine that all over the place, let's pull up ksatutils and let's write a quick convenience function, right? So we're going to say b8 ksat type is binary. That way there'll be one source of truth, right? And we'll say ksat type. There'll be one source of truth in terms of whether or not a particular asset type is binary. So let's go to the C file, and we'll just put this right down here at the bottom. We'll do just a switch on the type, and then we'll just auto fill that in. And essentially what we're going to do is we'll say default at the top, and we'll say that unknown and default are kind of the same. We will say, let's see, I guess we should probably do false at the top, right? So we can say return false, right? And everything else will return true, right? And then we can take the ones that are not binary and put them at the top, and ones that are binary and put them at the bottom. So materials are not binary, static meshes are, images are, height map terrains are not, I think. Scenes are not. Bitmap fonts are. System fonts are not. Text, of course, is not. Cason, of course, is not. Voxel terrain, we don't know yet. Skeletal mesh will not be, or will be binary, rather. Audio is binary. And then shader is not binary, right? So we might have to adjust a couple of those eventually, but this will allow us to essentially do. I'll just do it here for debugging purposes. Is binary equals kasat type is binary, and then we can just pass through the type. And then there is our file watch, right? All right, so that looks pretty good. So now we have our file watch ID. We need to add a entry into a watch list using a pointer to the asset as the base. So let's just to do this. Let me see. I once talked about NatViz stuff, but it turns out you can do that stuff with Python GDB script on Linux side. Basically, you can write your own custom pretty pointers, and even VS can visualize your structs, etc. more sanely. Yeah, I vaguely remember looking into that for a couple minutes, but I didn't get very far with that. Let's see. GDB stands for greatest debugger. I'm not mad at it. You're still on Windows 10 over there? Yeah. As of October, though, you're going to be in a pickle for sure. Let's see. Do you have a book? What would you recommend for programming overall? Learned a lot since I played around with WinAPI and User32 DLL, and I enjoy doing sometimes 5 hours nonstop. Yeah, I get it. Right. I write code all day and then come home and write code, right? Yeah, so how to avoid recursion and stuff, and what is redim const? Okay, redim that's a Visual Basic thing, I think. I haven't touched Visual Basic in 10 years, so I'm a little rusty on it. I don't fully remember what redim. I remember having to use it, but I can't tell you for the life of me what it was used for. Not at this point. Do you have it? So books on recommending on programming overall. Programming overall, no. Specific things, yes. So it depends on what kind of programming you're wanting to get into. All right. So we need a watch list of assets, right? And we're essentially going to keep the asset name, the package name, and its type, and then a pointer to the asset, which I'm kind of debating not even keeping a pointer to it, to be completely honest. Because if we really think about it, there's not really much need to. So let's take a look. Let's take a look at an example, right? So binary is probably one of the simpler ones. Let's actually get rid of some of these errors first so we can actually just look at the code. These are just the fields we deleted. I'm just getting rid of those. Okay, so let's see. So when we request a binary, let's go with the synchronous version, right? Because the asynchronous version is just a Jobified version of the synchronous code. Essentially, what this does is it makes a call to the VFS with a pointer to the asset, callback, and listener that are made. Oh, wait a minute. I said I was going to go with the synchronous version. Let's simplify it. Essentially, this is the flow of how an asset request works, and this is basically the same for every type of asset. Just this one's really simple. So in this case, we dynamically allocate an asset, a binary asset, right? And we set up a request for the VFS, and we request it. That returns to us asset data. That asset data in this case contains a size and the content, which we then take a copy of here, right? And so, let's see, wait, why didn't I just, okay, I'm going to actually simplify this code because I don't know why I did it this way. Let's do out asset content is equal to that, and then I don't have to do this. Copy memory. Oh, is it because of the, I think that's why. Because that's const. That's why I did it. Okay. All right, ignore that. All right, so essentially we take a copy of the data, and then we're done with it, right? So this is the simplest possible scenario in terms of assets, right? Other than a text file doing the same thing but with text, right? So if we come down here, delete these things, which will get rid of the errors. So, again, we just allocate, set up a quick info for request the data, get the data back, take a copy of it, and then we're done. So we have a dynamically allocated pointer to this already, and it's not tracked by anything other than what actually asks for it, right? So it's up to the caller to actually go ahead and release this asset at some point, right? Which is done here, right? Or for binary, it's done here. And so, in most cases, the way that you're supposed to work with assets is you request the asset. When the asset's loaded, you use it. So let's say for an image asset, for example, you take the pixel data, you upload it to the GPU, and then you're done with it, right? You don't need to keep that loaded in memory, so you release the asset, right? And then you don't have all that pixel data in memory. 9 times out of 10, that's generally what you're going to want to do. You're going to want to request the asset, read the data from it after it's been processed, and then release the asset. So my thought here is, with hot reloading, that we would probably do the same thing, where we would essentially create a new asset, right? That contains the hot reloaded data. And that would be what we then go ahead and pass along in the hot reload message, right? So I would, essentially just do this, right? The only problem with this is we would have to also figure out, how we actually need to allocate this and so forth based on type, which is not the end of the world. We could create another function like this, or have some way to sort of figure that out, right? Based off of this, anyways, we would have to figure out which sort of set of handling code we actually need to pass off to, anyways. So, I'm not too worried about this. We'll come back to that. But essentially, I'm thinking, whenever we hot reload an asset, we probably ought to wind up with a new asset of that type, right? And then that's what gets actually fired off in the message. Because chances are, even though we're saying, watch for a hot reload of an asset, we probably haven't held a pointer to that asset. And that's going to be true when we actually call this and its sort of, parent function that called it. So the more I think about this, the more I think we can actually simplify this further. We actually don't need. I'm going to say we actually probably don't need the specific version of this. I think we can actually just go back to just a single watch for reload, right? Because we don't need a pointer to the asset. The only thing that we would need to do is say, hey, watch for an asset of this type that's named this and in this package. And I think that is reasonable. So that's what we're going to do. So let's go to this, and let's get rid of this, because I really, now that I'm thinking about it, I really don't think we need it. We're also not going to make this static, right? We're going to call this, we're going to say asset system, watch for reload, and get rid of the internal, right? We're going to go to the top here, and we're going to get rid of this. And then we're going to take this guy, and we're going to go to here. And just before we get to the asset type specific stuff, we're going to put this right here, right? We're going to say asset system watch for reload. And then we just need to go to here. Oops. And I think that is a reasonable way to handle this, right? Oh, I need to make sure that that is and if. Now that I think about this, though, there actually is a slight problem with this. And that is, if we use this code as is, we are going to have to go through our entire code base and essentially check to see if, we're going to essentially have to do this through our entire code base because this may or may not exist, right? So what we really need to do is take this, and I'm going to rename it to underscore, right? And I guess just underscore is fine, right?
Love seeing the progress. I can recall Kohi episode number 1, quite the journey, and looking forward to seeing the fruits with your first game.
Holy crap, Meeborn, it's been a while since I've seen you. How are you doing? Thank you so much for the Prime. How have you been? Yeah, it has been a while. Yeah, I hope you're doing well, and thank you again for the Prime. Appreciate that. Let's see. I know you talked about Jason Gregory's game engine architecture in the past. How much of those techniques were adopted into Kohi? A lot of them. Yep. I haven't structured my engine exactly like what they talked about there. I kind of used it as an inspiration and took bits and pieces of it. But yeah, there's a lot of inspiration behind it for sure. So yeah. Okay, so when we watch for hot reload, what we're also going to need to do is we need to do define asset system watch for reload, right? And this is going to want state type asset name and package name, right? And what this is going to do is it's going to call this one. It's going to pass through state type asset name and package name, right? And so we'll have that, and that's going to be defined if hot reload is defined. If it is not, then essentially we're going to define this as a no-op. And we've seen this, and this is actually another, it's funny you bring up the book because this is another thing I picked up from there, is, we can set things up this way so that even our calls to this in code become a no-op, or basically just get if-def'd out, right? It becomes a no-op, essentially. We're saying define this to nothing. So if hot reloading is enabled, then this function is defined and or is declared and defined, and we have a macro to access that function. So we would not call this function directly. We would use the macro instead, because the macro becomes a no-op when hot reload is there, right? So that is kind of the thing that we're going to do across the board for hot reloading, so that we only get that compiled into the code at all if that's enabled. Let's see, all good here, trying to get some time to get back into hobby engine dev. Well, awesome, welcome back, glad to have you here. Let's see, caught another stream on time. How's the hot reload implementation coming along? Pretty good, pretty good. We've got a lot of it figured out in terms of the low level stuff, right? So we had a little bit of moving around of things to do within our file system. We actually went all the way down to the platform layer, which we haven't done in a long time, and made some changes there. I've only made those changes, though, at the Linux level. So I'm going to have to do those at the Mac OS and Windows later, and I'll probably forget to do that, and then people will be like, why is it broken? But yeah, we've completely redesigned the way that works, and made it a lot simpler to use than it was before, and a lot more obvious as to what's going on, too. So yeah, I think it's definitely much better than it was before. Okay, so in this case, we have watch for hot reload. We need to know. Let's see. We need to actually do a little bit of sanity checking here. So we need the asset system state, obviously. Type, I'm not really too worried about that. We can pass. I guess we could do some sanity checking on that, but what I really want to do is we want to make sure that asset name is not equal to invalid K name, and let's see, package name actually. Package name. We do have a lot of things that sort of default to the application package name if it's not provided. Do we have? We don't have that in here. Okay, I'm gonna put a to-do in here. To-do. If package name is not provided, use a configured default package. Because we have some things in game code where we don't necessarily want to provide the package name because we want to just say use the game package by default. So it might be nice to actually support that in code too, but for now, I'm not going to worry about it. All right, so for now, we'll just check and package name is not equal to invalid K name. All right, so we need to do some sanity checks on there. If any of that stuff fails or we don't find it or whatever, we need to do return invalid ID U32, right? So that's basically going to be our failure case for that. Okay, so we get a file watch ID here. That eventually we're going to return down here. Here when we're done. So we need to make sure to do that. And then we need to add it to the watch list. So I think we have everything here we need. We need to actually go to this state. Here we go. Let's see. So, we do have a default package name. Why did that not come up? Oh, we don't have it at the VFS level. Okay. Let's do this then. We'll say if package name equals valid K name, then we'll do package name equals state default package name. Right? So we'll just do that. And then we actually don't need to worry about that at the BSFS level. So let me just get rid of that to-do comment. Because I guess, yeah, it makes sense that that shouldn't have to worry about that at that level. Okay. Watch list. So we do have these asset lookups, which I don't think we're actually now using. Outside of yeah, we stand them up and don't use them. So instead of asset lookup, I think I might actually just, instead of having this, I think I might actually just completely rewrite this. So type def struct, and we're going to say this is a asset. How do we want to do this? Asset watch, I think. Right? So we're going to say asset watch. So the things that we're going to need is U32 file watch ID. We do need that. Hot reload context. I think we don't really need that anymore. I don't believe. Auto release. We don't need that. Reference count. We don't need that. We do need kname asset name. Whoops. Wow. That is not what I wanted. Kname package name. And then we're going to need kasset type. And that is everything we're going to need, right? So I guess let's just organize this a little bit. Okay. So let's see. Should we even store the ID there, or should that be part of the BST here? We do lookups of assets by name, but we actually want to look up assets by watch ID, which is not necessarily always in order. File watch ID, I guess. Okay, so let's do that. Asset lookup, that's going to be watches. Whoops. Right, so we're just going to call this watches. And we're going to say an array of watches, which contains name, type, etc. Okay. So we've got that. This asset lookup structure, I'm going to get rid of this. We don't need this anymore. So that's good. And then all we have to do is basically just fix wherever this is kind of broken. So lookups is going to be watches. And this is going to be asset watch times max asset count. Yeah, that should be fine. And then lookups. Oh, we have lookup tree. Let's see, do we want to say? Yeah. Let's clarify this. All right. So BST node is created when the first asset is watched. Okay. And then we want to invalidate all the lookups. So essentially the way this works is we have a list of these watches, right? And then we have a concept of a taken or a free slot. So we don't actually need this guy because that's the index, lookup index. So let's say a free slot here is when the asset type is unknown, right? We're going to consider that a free slot. So invalidating all of these is going to mean that we do watches. And then instead of asset, type. And then instead of 0, we're going to say k asset type. K asset type unknown. Right? So unknown equals free slot. Right? So on shutdown, we're going to have to do watches, check to see if watches exists. If it does, this is going to be watch. And then watches. And then, let's see. So the only thing that this needs to do is it needs to stop the watch, right? So if lookup, let me think about this for a second. Oh, you know what? This is not going to work completely as I thought. Poop. Let me think about this for a second. How do we get... So I need a way to look up the file watch ID. I guess we could just go ahead and store it, right? That seems kind of lame, but U32... I'm going to store it for now, and I'll figure it out later. I feel like there's a better way to do that, but... actually, is not equal to invalid ID U32. We should probably also do file watch ID is equal to invalid ID U32, right? So we'll do k-free watches size of asset watch times max asset count, right? So for each one of these, if the file watch ID is not invalid ID U32, then we need to do let's see, asset watch. We probably need to do platform unwatch file and just do lookup file watch ID, right? Because we don't really care about the VFS at this point, right? If we're shutting the asset system down, we're shutting the entire system down. So we'll just unwatch the file here. And then this whole thing we don't actually need anymore. So that should be sufficient for now. We might... Do we do this? I don't think that we... Let's see. Right, we don't maintain a list of these watches here. So this is not going to know to unwatch anything, which is fine. So we have to directly call this. That's fine. Okay. Okay, so that's the shutdown. What is the rest of this bleating about? Oh, it's going to be these. Let's go ahead and get rid of these. We remove these properties from the structure so they don't exist anymore. We had all these things set to false anyways. Right, so we can... Got just a couple of them left, I think. I could do it like all at once, right? But I don't really see the point of doing that. Okay, so that's eliminated all the errors there. Now, when we actually do the watch, we need to actually add it to that list, right? So we're not actually adding it to the watch list, which we have to do. So let's do. So let's do BST insert, right? The root is going to be state lookup tree. The key, in this case, is going to be file watch ID. And then the value is going to be an index into the array. So we have to loop through the array. So I'll do U32 index equals invalid ID U32. And then for U32, I equals 0, I is less than state max asset count plus I, right? And then we'll do if state watches sub I, and we're going to do type equals asset type, k asset type unknown. Then we do state watches sub I type equals type, state watches sub I file watch ID is equal to file watch ID state watches sub I, package name equals package name, and then asset name equals asset name, and then we want to break, right? And at this point, if index is equal to invalid ID user 32, then we bleat about it and say no space left in the watch cache. And actually, let's actually turn that into a fatal, because that is an issue, right? Return invalid ID 32. And then also, we forgot to set index equals I. Right? Okay, so we have that. The BT node value. BT node value. We want to set that to, we want to use U32 is equal to index. Right? And then we just pass V here. Right? And that, why is that complaining? Does it need the address of it? Oh, I see what I did. That should be there. Okay, so this is going to be BT node, new node is equal to that, and then if state lookup tree, if that is null, then we're going to say state lookup tree is equal to new node, right? Now, so essentially what we're doing is we create the watch, fill out this information at that index. The index becomes I, we do a sanity check on that, and then we insert into our binary search tree. The key is the watch ID, file watch ID, so we can very quickly look that up, get the index, pull from the array, and then we use the index as part of the node value V. And if this is the first node in that tree, we go ahead and set up the base node. So this is no longer a to-do. That's just doing the thing now. All right. When an asset is destroyed, make sure its entry is removed from the watch list. So, damn it. That was my reason for keeping a pointer. Well, no, not necessarily. I don't think we actually need to do this. Because remember, the asset could be released, and we could request it again, even though it's being watched for hot reload. So this is actually relevant. How do we handle knowing the asset type when hot reloading? Okay, so that is done. We do have the type. We have it here. However, we need to figure out, okay, now we need to allocate some space for the new asset before we actually kick off the hot reload function, right? So let's go ahead and just map this out so we can figure this out in our head, right? So we're going to set up an event context. The context data U32 is going to equal the file watch ID. And then we're going to do event fire. The code is going to be event code asset hot reloaded. Let's see, the sender now is going to be out asset, right? And we're just going to take that with a grain of salt for right now. And then do EVT context. Right? And there we go. Right? So that's essentially the way that this is going to work. Oh wait, this is watch for hot reload. We don't need to fire this. What am I doing? We don't actually need to do this until this is actually done when we get when we handle the event of it being hot reloaded. Okay, all right, so let me think. So now we need to register. We need to register for the hot reload events, right? Because I don't think that's actually done here. So we actually need to handle that next. Let me just catch up on chat really quickly. Thank you for the follow. Appreciate that. Let's see. Only use C? Yes, we do. I don't know any of this, but I do know Minecraft commands. Fair enough. Fair enough. Welcome, though. All right, I guess I probably got to register for these and then think about winding down for the night. So, asset system initialize. What we need to do is register for VFS load delete events. Right? So I'm actually just going to paste this here. We're not leaving this here. I just don't want to lose it. So we want to do, how do I want to do this? So if we look at event H and then event fire, or actually I guess we want the PFN on event, right? We want this. We want that type. Okay, so we probably ought to make that a static function. So we're going to have static B8, and this is going to be, we're going to have two of these. So I guess I want to call this, let's call this asset file written. Actually, we'll say VFS file written. And that'll be that one. And then we'll do another one for VFS file deleted. Right? So we'll have those two. And then I'm going to come down here and just paste these real quick. But I'm going to move this to here. Right? Okay, so we need event register. And then we need event code VFS file written to disk. The listener is going to be the state, right? So that's going to be state, so that we can pull everything we need from that. And then on event is going to be VFS file written. And then we're going to do pretty much the same thing, but for deleted. No, that's not what I wanted. Isn't it? VFS file deleted from disk. Why is it not? There it is. Okay. And this is going to be deleted. Right? So we have those two. We're going to take these, go all the way down to the bottom of the file, where the rest of our static stuff is, and we'll put them here. So, from this, we need to go ahead and say if code equals event code file written to disk, right? Then we want to go ahead and process the event. Otherwise, we don't want to do anything with it, right? So we just want to double check to make sure that that's, we're dealing with the right message there. Here we could also do if code equals event code deleted from disk to do notify or something. I don't know that we actually need to do anything here for an asset being deleted, but maybe an editor or something might need to know. All right, so how do we handle knowing the asset type when hot relating? So the first thing that we're going to need to get from this is a couple things. So we need the sender is going to be the state. So we want, let's see, we need asset system state equals asset system state sender, right? So we get that. Wait, no, that's going to be listener, not sender. My bad. Listener instance. All right. And that's going to be true for this guy too. I'm going to comment that out though, because that's probably going to break things where it's not used. Okay, so we have that. And then if we recall in our comment here, it'll actually tell us how to use it. So the watch ID is context data U32 sub 0. So I'm actually going to yank that and let's see, that's going to be called data. That's really annoying that that's called data. That should be context. And get rid of that. So now we have the watch ID. And then what was the other? It was the sender was the VFS asset data, right? So VFS asset data equals VFS asset data sender, right? So we've got that as well. And then the other bit that we need to do is we need to say BST find, right? And so this is going to be state lookup tree, and the key is going to be the watch ID, and that's how we're going to get that. And then let's see, I think this returns a node from which we can get the value. So const bt node node equals that, right? If not node, then essentially we have a watch ID that isn't registered in the system. We should probably actually turn that into like a k-warn, right? It's not critical. It's not gonna. It shouldn't like cause the application to crash, but it should make you go, "What are you doing, you dingus?" All right, and we're also at this point going to return false to allow other listeners to handle the event, right? In fact, we're going to do that no matter what, but we want an early boot out there, so we'll do that. Okay. So from this, then we can say node value, right? And this is going to be U32, right? And so what we have here is the U32 index equals this. And so what we're going to use that for is then we can say asset watch equals the address of state watches sub index. And then boom, we have the watch with all the information that we need. So we can do switch watch type, right? Handle the asset, handle the asset by type when hot reloading. Okay. So that is actually where I'm going to leave it for tonight. In fact, let's do that. And I will save the session too. So we've actually made pretty good headway. Now all we need to do is actually handle reading in from this asset data, specific by asset type. So that means that we'll probably have to go through here and extract out some of these specific types of handling of assets by type to functions, so that we can just not repeat ourselves. And then when we get to there, we just call that function from here or up there, and then after this, we essentially also to do fire off a message that the asset was hot reloaded, right? And then it's up to the individual system on how to handle that. All right. Thank you for the follow. I appreciate that. Let me just answer a couple questions, or maybe one question, because I've actually got to go. Hey, where did you learn all of this? Years of practice, looking at other code bases, and frankly, just writing code. It's amazing to see you keep writing code like it's nothing. Yeah, I mean, sometimes you just kind of get into a flow, right? It's just kind of the way it works. But yeah, I mean, I've been coding for, I don't want to think about how many years, but since I was 7. So it's been a minute. All right. So with that, thank you, Spiro. I appreciate you hanging out. By the way, for those of you who aren't following him, um, shout out to Spiro. He's a mod here on Twitch, but if you guys aren't following him, you should definitely do it. He's always coming up with or bringing the tech news to the audiences, in a based way. So yeah, definitely go check him out if you haven't already. He's also working on a really cool game project where he's writing a game engine in C, compiling that to WASM, and then using the HTML or using the DOM rather in the browser as his renderer, which is very outside the box thinking. So definitely go check his channel out. And I'm going to find somebody to raid. If I can hit the right dingus button here. Let's see. See if I can find something kind of similar / related to what we're doing. Let's see. Preferably something in English. All right. Actually, there's somebody here. It looks like they're doing C++, SFML, and Box 2D. Haven't rated this person before. I have not met them, but they've only got 2 viewers, so show them some love. We are going to raid Observer Herb, and let's see what they're up to. I am going to have to raid and run, so you guys will have to keep them, busy. But yeah, show them some love for sure. Yeah, I will catch you guys next time. Thanks so much for being here, and I will see you guys later.